Consider a uniform electric field E bar oriented in the x direction in empty space. A cube of edge length L is placed in the field oriented as shown in figure. Find the net electric flux through the surface of the cube. So in this task, we need to find what is the electric flux through the surface of the cube. Electric flux through it. First of all, let's recall what is electric flux. So flux we define as the number of electric lines of force passing through unit area is defined as electric flux. So we can write flux as electric flux. Electric lines of force per unit area. Electric lines of force or electric field lines. Electric field lines per unit area. What does it mean? Suppose if I took a positive charge at here, so we know that from the positive charge, electric field lines will go in 3 dimensions. In all the directions, electric field lines will become along in all the directions. Suppose if you take one particular area, so I can take only in this direction. So in this phase, how many electric lines of force are passing? Suppose if you can take the surface area A, B, C, D, how many electric field lines passing through that area? That area A, B, C, D. So this we defined as electric flux. So in formula manner we can write flux pi equal to E bar electric field vector times A bar. A bar is area vector. So the dot product of electric field vector and area vector we can define as electric flux. Flux suffix E we can define as electric flux. So we can write as EA cos theta. So this is the dot product. If you see in this diagram, so this is the electric field due to positive charge in one dimension. If you can see a charge in a place from the top viewpoint. But the next diagram, if you can see at here, if you take this charge at the origin in the 3 dimensions, so we can notice that electric field lines are coming out from this 3-dimensional surface. So if you need to find it out what is the electric flux through this surface, so on the top surface if you can take what is the electric field lines through this surface, so that we defined as electric flux. So there we need to draw what is the area vector. So this is the area vector. I need to find what is the area of the surface. Suppose if we can take this A, B, C, D as area, and I need to know how many electric field lines are coming. That we define as electric flux. In a formula manner we can write flux pi equal to E bar dot A bar. So the number of electric field lines crossing through unit area is defined as electric flux. You can show that is in the same the diagram at here. If you can take, this is the figure. So how many electric field lines are passing through this given surface. So the number of field lines are passing at here. The number of field lines are the passing at here. So that is the flux through that surface. So in the coming series of the problems, we will find how to find the flux in the given problems. So you can take this problem. Now we need to find what is the electric flux through the surface of the cube. So here how many surfaces are there? So they are given as 1, 2, 3, 4. Now I can take as flux through surface 1 as suffix 1 equal to E bar dot A bar, which is equal to EA cos theta. Now I know the electric field directions. So if you can notice it here, electric field is along positive x-axis. So we can take as unit vector along I cap. And here A bar is along the negative x-axis. Since we need to represent area vector, so that we can take as negative I cap. It means electric field vector is along the positive x-axis and area vector is along the opposite directions. Now if you take that, what is the angle between electric field and area vector? So here it is, theta is the angle between electric field and area vector. If you can say, they both are, electric field is along the positive x-axis and the area vector is along the negative x-axis. They both are the opposite in the directions. The angle between them goes to 180 degree. Now I can substitute that theta, the theta value at here, theta equal to 180 degrees, because E bar and A bar are opposite. Now if you can write electric flux through the surface S1 equal to E times, what is the area? So to find out the area, they are given side equal to L. So area becomes as an L times L cos 180, which is equal to EL square cos 180 value minus 1, which I can get minus EL square. That is flux through the surface S1. Now what is the flux through the surface another surface? Now to do the flux through the another surface, now if I can take flux pi s suffix 2 equal to E bar dot A bar equal to EA cos theta. Now I would like to find the flux to the surface S2. Now this is the one. Now if you can see in the figure, the area direction and electric field direction, they both are along x-axis. If you can assign in this case, electric field is also unit vector along I cap in the x-axis and the area vector is also along I cap. Now if you can write that in the formula, what is the angle between them? So here theta equal to 0 degrees. Reason? Because E bar and A bar are parallel. Now you can find it out. EA cos 0 degree, the area same side, it will becomes L square. Let me write it properly. So E times L square cos 0 value 1, So you can get that E times L square, that is the electric field due to surface S2. Now let's see, calculate the flux through third surface. Flux through surface 3 equal to E bar dot A bar. Now if you can take the third surface, so this is the third surface. Now we need to figure it out, what is the angle between electric field vector and area vector. Now if you can see clearly, so this electric field vector is along y-axis, means unit vector along j cap. Sorry, that is the area vector. Area vector is along y-axis j cap, and electric field vector as usual it's along I cap. Now the angle between area vector and electric field vector, here it is 90 degrees. So if you can write that EA cos theta. Now in this case theta equal to, here theta equal to 90 degree, because area vector, area is perpendicular to direction of electric field. Area is perpendicular to E bar. Now if you can find it out, what is the flux through the surface 3, third surface, equal to E times A cos 90 degree. So area L into L, L square, cos 90 value 0, so the total value becomes 0. So flux through the surface 3, the value goes to 0. That is third. Now we need to figure out what is the flux through surface 4. So by seeing the symmetry, you can understand that the surface 3 and surface 4, they both are opposite, and not only that, the area vectors also opposite. Therefore let us see what is the flux. Flux through the surface S4, flux through the surface S4 equal to E bar dot A bar, which equal to EA cos theta. Now see from the figure, what is the direction of the area vector along with the electric field vector. Now in this case, area vector is a downward direction. So if we can assign that, so that gives to me along negative y-axis. It means in the unit vector I can mention that it's minus j cap. Now what is the electric field vector? Electric field vector is along I cap. Now what is the angle between j cap and minus j cap and I cap? They both are perpendicular. So here theta equal to 90 degree. Reason? Because area is perpendicular to electric field vector. Now in this case also we can guess cos theta value will becomes 0. The flux to the surface 4 equal to EA times cos 90 degree, area where L into L, you can get L square, cos 90 value equal to 0, the final value goes to 0. Now we found out what is the flux through the 4 surfaces, the flux through surface S1 and the flux through surface S2 and flux through surface S3, third surface, and the flux through surface S4. Now combine all these values, we can get net flux through the surface of the cube. Therefore net flux net flux through the surface of the cube I would like to call that as phi equal to flux through the first surface minus E times L square plus flux through the second surface plus E times L square plus flux to the third surface is 0 and flux through the fourth surface is equal to 0. Therefore, net flux equal to 0. It means the total number of electric field lines are coming out through the surface is equal to 0.